Okay, so one more topic that I was silly and forgot to put in the last video, whoopsie, is this idea of quadrantal angles. These are the angles like 0 or 360, 90, 180, and 270. Or when it comes to radians, 0 to pi, this guy's pi over 2, this guy's pi, and this is 3 pi over 2. So as far as trig function, these guys, sine, cosine, tangent, and all their buddies, it relies back on this information that we talked about in a previous section that says if you are given a point, x, y, on the terminal side, then this equation holds true. And to find your trig values, you have those formulas for it. But we talked about how in a circle, here's the terminal side. You can kind of sketch a little right triangle. This is x, that's y. This is the radius of the circle. So if you're given the xy and apply x squared plus y squared equals r squared, then you have x, y, and r, and it's just a matter of plugging them in. But if this is your angle right here, then y is actually the opposite value, x is the adjacent value, and once you find r is your hypotenuse. So you can actually just think of these again as opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. Now, if you notice these down here, there were these specific restrictions. X could not equal 0, y could not equal 0, x, and y, because division by 0 is not allowed. Well, the only places that happens are these axes right here, right? On the x-axis, the y equals 0. Whatever the x value is, y is 0. On the y-axis right here, whatever the y value is, x will always be 0. These are called the quadrantal angles because of that, because they are on an axis, so we can't pull this whole trick of drawing a perpendicular line and forming a triangle, because they're either straight up and down or straight left or right. So instead, we have to use what's called a unit circle. So basically what a unit circle is they took this regular old circle, right? Let's say it had this point right here on it, coordinates, whatever angles, and the coordinates were 2, 2. I'm making this up as I go along. And if I told you that the radius was 4, and I wanted to scale it by a factor 1/4, all that means is I have to take all these values and multiply them by 1/4. So I'd go 2 times 1/4, that's 1/2, that's my new x. And then y is the same value, so it would be 1/2 as well. And that would change this r to 4 times 1/4 or 1. And what that's done is produce this new triangle that's, inside here, much smaller, to where this distance, my new r is 1/2, just 1. And that same point right here is the actual new coordinates of 1/2, 1/2. This is geometry, and it might not click in your brain, but that's the idea behind this whole quadrantal angles idea, to find the trig functions of them. So the easiest way to do it is to picture this as a unit circle meaning r is 1. Basically, no matter what size the circle is, whatever the radius is, we would just divide by that number or multiply by its reciprocal to turn the r into 1, which means this distance from the center out to the edge of the circle is your radius, which is always going to be 1 in this unit circle. That's what makes it very specific. So the distance from here to here is 1. Distance from here to here is 1. These are all radii, right? This is also 1. Which means if we were going to now do our coordinates, this point right here, because it's 1 from the origin out to here, that's the x value. And because we're on the x-axis, our y value is 0. Up here at the 90-degree point, right, angle from here to here is 90 degrees. Now we're on the y-axis, so this is x of 0, and we went up on the y-axis, which makes our y 1. So over here, this is our x and y. Now over here at 180, here's my point. I've gone in the negative direction 1 unit. That makes my x negative 1. And my y value, because I'm on the x-axis, is still 0. Okay, down here at 270, I've gone down 1 on the x-axis, which is why y is negative 1. Sorry, down on the y-axis. And x is 0 because I'm on that axis. Notice it's just a blend of zeros and ones and negative ones, depending on which axis, tells you which one has a value of 0, and then depending on which direction you go, right or left versus up or down, is what makes it the positive or negative. Okay, so what do we do with those? Well, if you think about those formulas, the sine of an angle theta, when you're given an xy, right? Given xy, you can find r. But luckily for this one, our r is just 1, so you don't actually have to do that because r will always be 1. Very specifically, r is 1. Then our formulas from this are going to be way simplified. So the sine of an angle is equal to y over r, but since r is 1, well, y divided by 1 is just y. So this simplifies down to the sine of an angle on the unit circle only. It has to be the specific unit circle, is just equal to the y coordinate. So over here at 0 degrees, the sine of 0 degrees is 0 because that's the y coordinate. Then our other formula was for cosine. The cosine of theta is x over r, which is x over 1, right? Our radius is 1, which is just x, which means on this unit circle, the cosine of theta is just going to be the x value because r is 1. Okay, so over here, if I ask you what the cosine of 0 is, you would say, here's the x value, 1. Okay, let's move up here to 90 degrees. Okay, x is 0, y is 1. That means the sine of 90 is y, so it's 1. Cosine of 90, the x is 0, so it's 0. It is all about these values right here. Okay, let's try, let's see, let's do 180. I'll have to come down here for it. So the cosine of 180, cosine is x, so the answer is going to be negative 1. The sine of 180 is the y value, so it's 0. Okay, over here at 270, the sine of 270, that's the y value, so negative 1. And then the cosine of 270 is going to be the x value, which is 0. So all you have to remember is the ones and zeros and where they're placed, but based on the unit circle, it's just ones and zeros depending on what axis they're at and which side they're at. Okay, so now what about tangent? Tangent's formula was the y value over the x, which means the y coordinate over the x coordinate. Okay, let's try 0. Tangent of 0 is the y, which is 0, over the x, which is 1, which is 0. Okay, how about 90 degrees? The tangent of 90 degrees is the y, which is 1, divided by the x, which is 0. Uh-oh, can't divide by 0, right? It's illegal. What happens? The world blows up, whatever. We just call it undefined. Okay, over here at 180. Tangent of 180, again, it's y, which is 0, over x, which is -1. 0 divided by anything is just 0. And finally, 270, y is -1, x is 0. Uh-oh, woo, not allowed, so it's undefined. So this idea of a unit circle is something that can be explored for any of the angles on our unit circle right there, 30, 60, 90, 210, all of them. But the main thing it's important for is these quadrantal angles. So each quadrantal angle, their value is computed just by those zeros and ones. And then their buddies, their reciprocals, just have, just like before, their reciprocal numbers. It is. So here's a little table that tells you all of them, right? 0, 90, 180, 270, 360 is the same as 0. Here's your sine and cosine values. Now, if tangent is 0, that means it was either 1 over 0 or -1 over 0. Well, when you get to cotangent, that's flipped, right? The reciprocal, which would be 0 over 1. Or if you had 0 over 1, when you reciprocal that, that's 1 over 0. So if you notice, anywhere tangent is 0, cotangent is undefined, and so forth. And then anytime sine is 0, the cosecant is undefined. It's all about division by 0. The sine, cosine, and tangent are the main ones that you want to pay attention to, and then you can always do the reciprocal to find the other ones.